And I'm not seeing the URL for the live stream, so I would like to share that.
I'll send it to you.
Okay, thanks. On Facebook.
Okay. Yeah.
Cool. So we have Levi here from Mostly Serious. Thank you for presenting on browser extensions. So looking forward to seeing what you have to do. What do you do at Mostly Serious?
I am a front-end engineer at Mostly Serious.
Awesome. Very cool. How long have you been there?
Since January.
Cool. Very awesome. Thank you for presenting.
Yep, no problem. We good, Jason?
Yeah.
Okay, so as she mentioned, my name's Levi Zitting. I work with Amy Hendricks over there and Miranda Provance, who's not here tonight, at Mostly Serious. I'm a part of their engineering team. I mentioned I'm a front-end engineer, so that's a lot of HTML, CSS, JavaScript type stuff. I do a little bit of back-end occasionally and some Python and PHP, but definitely mostly front-end. So I'm here today to talk about browser extensions, kind of what they are, what it takes to build one, what are the tools and technologies that you use, and kind of what they're capable of. So I have some notes here. Let's talk a little bit about, let's start with what a browser extension actually is. So a browser extension is a set of code files, a program essentially, that can alter a user's browsing experience. So they're installed into your web browser. This can be Firefox, Microsoft Edge, Google Chrome. There's a whole bunch of browsers that support browser extensions. And they can alter web page content. They can interact with low-level browser APIs. And they can also add custom UI to a browser in some way. Some examples of some really cool extensions. Who here has heard of AdBlock before? That might be a little bit of a popular extension. It blocks ads on websites. That's a cool one that I usually use. There's some really simple browser extensions. A really fun one is GitHub Dark Theme that changes all the styles on GitHub's website to be much darker instead of the bright colors that they normally have. There's also DevTool extensions. So if you use some modern front-end frameworks like Vue.js or React, there's extensions you can install that enhance your development experience with those specific frameworks. Another really crazy extension that has like a big team behind it that I use occasionally is Grammarly. That one's kind of like a full-blown application wrapped up into a browser extension, and it kind of listens for you typing stuff into web pages and then make sure that it's grammarly correct and grammatically correct. Sorry, grammatically correct, and also checks for typos and stuff like that. So there's a lot of things that browser extensions can do. I have actually kind of a list of some of the cool APIs that they have access to. So one, I mentioned they can modify the content of web pages. They can be scoped to modify them to just specific web pages, or they can modify like any page that's loaded. And there's a couple ways that this can happen. It can like actually make HTML modifications through normal browser APIs, or you can add like styles like the GitHub Dark Theme that I mentioned earlier. They can manage tabs and windows, so you can programmatically listen for events on tabs and windows, and also create and destroy tabs and windows. You can manage a user's bookmarks, so there's a whole API for interacting with a user's bookmarks. You can have a browser extension that is a VPN client, so there's actually like a few popular VPN clients that are just browser extensions at the end of the day. There's a whole API specifically for implementing a VPN client. You can add items to context menus. This is a little bit of an interesting one. Whenever you right-click onto a web page, that menu that pops up, browser extensions are allowed to add custom items into that menu with custom functionality. You can add features to DevTools, as I mentioned, just like the React or Vue DevTools. And you can even break down even more and like add features to specific parts of existing sections of the DevTools. So if you want to add something to the network tab specifically, you can do that as well. They can store arbitrary data. So if your extension holds like user settings or something like that, there's an API for specifically storing that data on the user's machine without having to like reach out to a server or anything. And also, that same API will work with synced data, meaning that if a user is like logged in with their account into multiple browsers, Google Chrome and Firefox kind of both support this. You can have like a Firefox account and then log into multiple Firefox browsers. Your extension has the ability to sync like random pieces of data across all those browsers without you having to introduce any kind of servers. Another interesting use case for extensions are screen recording. A lot of kind of web apps that do video conferencing usually will have you install an extension in order to share your screen with the person that you're talking to. And then that's all done through a browser extension. There's APIs for that. And then kind of the last thing that I have listed here is the ability to communicate with code on web pages. So if you have a web app, specifically kind of back to that whole needing an extension to share a user's screen, these web apps will communicate with the browser extension in some particular way in order to kind of start off the screen sharing session or something. There's a whole bunch, there's tons of more APIs. It's kind of just like skimming the surface of a handful of them. So they're really versatile, and these are all like things that we normally can't do in just normal web pages. So let's talk a little bit about kind of I want to talk a little bit about the architecture of a basic browser extension. What are the minimum amount of files you need to have, and kind of how do these files communicate with each other, because it's slightly different than just a normal website. And this was kind of something that, kind of like a reason I jumped into browser extensions is because I wasn't even sure what they were. How did I make them? Did I have to write native code, like in Python or C# or something, in order to add features to my browser? But the answer to that question that I was trying to find was actually no. You write your browser extensions in mostly just JavaScript, HTML, and CSS. So everything starts with a manifest.json file. And I'll get into kind of differences between different web browsers in just a second, but for kind of the 90% use case, usually it starts with a manifest.json file. And I have an example of one of those right here. It's going to be the one that we use for our actual, I have like a demo put together that we'll go through, but I'll just pull this up really quickly and show off kind of what's in here. So we have like the name of our extension, a description, a version. There's a couple other things in here, like we ask for specific permissions. Usually when you want to use all these different APIs that I listed, you have to explicitly ask permission so that when users install your extension, they know what it's capable of. Because extensions can do a lot of scary stuff, kind of. And then you also kind of list out the various files that you pull into your extension. I'll break down this even more when we jump into the demo. But and I'll jump into this part actually next, kind of what these background and content scripts and all these other things are. So it all starts with the manifest.json file. We load this file along with some of these other files listed into our web browser, and then the extension is installed at that point. So let's kind of start with content scripts. You see this little section right here in this configuration file. So content scripts are JavaScript files that are injected into web pages as soon as they load. There's a couple different options specifically when I'm defining a content script in here. There's this matches, which is just an array of like URLs that I want to inject this script onto. So if I was writing the GitHub dark theme, I would say I'd probably have like github.com in here so that my extension only gets loaded into the github.com code. You can also kind of specify when this file runs. You can actually run this file before any page content is loaded to maybe like add, I don't know, custom loading spitters or something like that so that every website has one. There's lots of use cases for the run at, but normally you probably, if you're writing like the GitHub dark theme or something, you want like the document idle, which is as soon as all the pages JavaScript has finished running. That's usually kind of the point you want to jump in at. And then you list out the files that get loaded at that URL. A little bit of an interesting thing about content scripts is that they run in what's called a different execution context. That means that they don't have access to all of the same variables that your normal web page has access to. It has access to most of them, but kind of a specific reason that they do this is so that you don't accidentally define a variable in your content script that collides with a variable that exists on the web page it's being loaded on. So they make sure that everything is namespaced off accordingly. But they still have access to things like the document APIs, so you can go select web page elements and make modifications to them. And they also have access to pretty much all the APIs that exist on Windows, so scroll event handlers and all that sort of stuff. So that's the content scripts. The next little part that I'll talk about is a popover page, or in this case they call it a browser action, which I'll jump into that in a few minutes. But a popover page and an options page, these are HTML files that I can add alongside my extension. And these would be displayed whenever I go to my extensions like options. There's a space in the browser extensions page where you can view an extension's options, and it would just load this HTML file. And then also a lot of extensions, they'll add additional UI to the browser, usually through like a toolbar button up at the top. And you can define what's called a pop-up, and that is the HTML file that will be displayed in a little small window when the user clicks on that toolbar button. You may have seen this in extensions like AdBlock. They tend to keep all of their settings just in that popover instead of an options page. Our demo uses the popover stuff, or pop-up stuff just a little bit. But those are a couple other files that that you can include in your extension. And you can also add JavaScript and CSS files to these pages like you would any normal web page. Something to be aware of is that neither of these pages have access to any of the content that is on the user's current web page. Something that kind of tripped me up when I was first getting into extensions is why couldn't my JavaScript in my pop-up access something on the page I was currently viewing? But it's because it's actually treated as a totally separate page. The last thing that I'll jump into in terms of this architecture and how these are structured is this background. So background is where you define what are called background scripts. And these are JavaScript files that run in the background of a web page. And usually, I think in the Chrome documentation, they describe background scripts as your extension's event handling script. So normally you'd have, this is kind of the file where you would interact with most of these APIs that I just listed out. The content scripts and the scripts on your options and pop-up page, they do not have access to a lot of these APIs. They're very siloed off in that sense. So the background script is where you would actually interact with a user's tabs and the screen sharing APIs and all those that I mentioned a few minutes ago. And so there's a lot of event handling code in here because a lot of the architecture behind these APIs is very event driven. You'll notice that a little bit as we jump into some code here. Another thing that I'll mention is that this background script is totally siloed off from the actual content that the user is viewing. So when they're on a web page, your background script cannot reach into it and make modifications. That's kind of what content scripts are for. And the whole reason behind this is so that there's no way for a web page to kind of try and hijack an extension to get access to those APIs. So it's kind of like from a security standpoint, that's why they're totally siloed off. And these ones are even more siloed off than the content scripts because they actually don't have access to the document variable or the window variable or anything like that. They are very much just for accessing the browser extension APIs. Another thing I'll mention about background scripts is there's a couple of options when creating one. You can specify a background script as a persistent background script, which means that it'll always be running in the background. If you disable this feature, Chrome will try and decide when it needs to spin your background script up to handle specific events. Usually you would want to set it as non-persistent in order to save your end users a little bit of resources, because running a script in the background all the time takes a little bit of memory. And this is probably why a lot of people complain about Chrome or other browsers taking up so much memory, is because a lot of extensions can be just constantly running scripts in the background that use some stuff up. So if you want to be nice to your users, try as hard as you can to make your background scripts be non-persistent. I will mention that if you need the ability to kind of schedule certain actions to be run through a background script, there's an API in the browser called the Alarms API where you can set an alarm that will trigger something in your background script at a later time so that you still can set it as non-persistent and get some kind of automatic changes or whatever happening. So those are kind of the four main pieces. Really just kind of three. The popover and options could technically be the same. In the case of AdBlock, I said they kept their options in the pop-up. But those are kind of the three main sections. Now, just before I jump into the demo here, I kind of want to say a few things about building extensions for the various browsers that exist, because there's a few that lots of people use. Chrome is kind of the base one. Chrome has a lot of users, so if you're going to be making an extension, it makes a lot of sense to make it for Google Chrome first. And Chrome, I think, was one of the major browsers that first added extensions. So they were kind of the big push behind a lot of these APIs in the first place. Now, let me take a second and talk about Firefox and Edge. Both of these browsers adhere to a brand new spec that is currently making its way through the W3C called the Web Extensions API. And the Web Extensions API is actually modeled exactly after the Google Chrome APIs. So for the most part, you can actually use the same code you would normally and just change a couple of things. There are some differences between browsers because not every browser has the same feature as every other browser. But for the most part, these Firefox and Edge have implemented this API that works just in tandem with the Google Chrome APIs. Opera, that's kind of an interesting one. Opera is kind of technically Chrome underneath the hood, so they just have the same APIs as Google Chrome. The really big weird one in the bunch is Safari. Safari has no interest in making the Web Extensions API work on their platform. And the reason behind that is Safari extensions are actually macOS applications that add an extension to their application. So whenever you install a Safari extension, you're actually installing a macOS app. And then the content script part of a Safari extension it works mostly the same as the way before. The scripts get injected into web pages and stuff. But when it comes to that backend script side of things, where you need to access all the browser APIs, you actually have to implement all of that in Swift code. So because it's a part of your macOS application, you have to write it in Swift, and all these APIs are only available in Swift. This is kind of bad, but also kind of interesting because you can get some really, really tight integration between your macOS application and your actual Safari extension, which isn't available on most of the other platforms without introducing some kind of server to sync data and those sorts of things. Another thing that I'll mention, I mentioned that there's a pop-up you can add with just an HTML file to Chrome and the rest of the browsers. You can do the same thing in Safari, but all of that UI has to be implemented with macOS native elements and also with Swift code. So a lot of your browser extension in Safari would be written in Swift instead of the way the rest of them are written with just normal JavaScript. Okay. With that being said, I think we're ready to jump into the demo. Get some water here real quick. This isn't 100% a demo. It's kind of a walkthrough as well. We're going to write a little bit of code because what I have here is actually just a really simple web app, kind of, at the end of the day, that we're just going to turn into a browser extension. So let me pop up my sidebar in my editor here and kind of walk through the directory structure of this application. So what I have is a really lightweight Vue.js application. Who here has heard of Vue.js before? Okay, most people know what it is. Vue.js is a JavaScript framework for making implementing user interfaces a lot easier. So I'm using Vue.js along with a component library for Vue.js called Vuetify. It's very similar to something like Bootstrap, just makes things look a little bit pretty because I'm not a designer. And it would look very ugly if I didn't use something like that. So you don't need to know a lot about Vue.js because I'm just using it to handle the UI side of things. And all that code is already written. The only thing we're going to do is interact with the actual browser APIs. Another thing that I'll mention is this is an extension that's just for Google Chrome. I'm not adding in support for the rest of the browsers, but theoretically, it would be pretty easy because they all adhere to roughly the same standard. So I already went over this manifest.json file, which is kind of the entry point into our extension. The rest of the main code lives in this source directory. This contains a whole bunch of JavaScript and what are called Vue files. This is kind of specific to Vue.js, and it's how we implement what are called components in Vue.js. We won't have to dive too deep into what those entail, but we can write kind of JavaScript and a mixture of HTML inside of them. We have this background.js, which is the background script. We'll actually load that in as a background script. And then we have this content.js with a little bit of code in here. Then this is the actual content script that will be injected into the web page. The rest of these are kind of all specific to Vue.js. Now, let me talk a little bit about the browser extension that we're actually going to be building. It's got a great name. It's called Word Replacer. It takes a list of key value pairs and looks for the key on web pages and replaces them automatically with the value. I've seen another extension like this that would try and hide like Game of Thrones spoilers whenever a new season of Game of Thrones came out. It's kind of a very simplified version of that. Then we also have the static directory with an HTML and our manifest.json file. These are files that we don't need to process in any way. Everything in our source directory actually needs to be piped through a build system first before it actually gets executed by the browser. But after we run the build command, at the end of the day, what we're left with is this distribution folder, shortened to dist, and it contains the compiled versions of the rest of all of our code. And the manifest.json file and the index.html file are just copied into this folder at build time. So this is the folder that we'll actually give to the browser and tell it to load the extension. So let's actually start by loading the extension in my browser. So what we're looking at right here is the the browser extension management page in Google Chrome. So this kind of lists all the extensions that I currently have installed. And when we're ready to develop on our extension, there's this developer mode toggle up here that we turn on, and it adds this toolbar right here and lets us load an unpacked extension. There's also this option here for packing an extension. What this means, whenever we're ready to actually upload the extension to the Chrome web store or whatever browser store we're trying to distribute our extension on, we would pack our extension, which essentially just zips up all the files into a single file, and then signs it with a cryptographic key that we'll need to hang on to, so that only we can push updates to our extension later. But for now, we'll just load our unpacked extension, which is just going to be all the source files. So let me navigate to my folder where the extension is and give it that dist folder. And you can see it added my extension here, and my extension also has in the manifest.json file, has this browser action default pop-up, and so it automatically added this little icon here into my toolbar. Now I have a pop-up page added into my extension, so I actually have like a little bit of a pop-up that shows up here. The only thing it does is it's just a quick link to the options page, because most of the UI for our extension is in the options. And another way that we could get to options is if we go to the details screen of our extension here and scroll down to the bottom, there's where is it? Extension options right here, and that takes us to the options page. So either one of these would take us to that options page, which it just opens in a new tab. So what I have here is kind of some UI for being able to add a word and then say what we want to replace it with. And if we click add here, it adds it into a list. But the first problem we'll run into is as soon as I refresh this page, I have the finished version loaded up. One second, let's remove a whole bunch of code real quick. This might take a second to run. And I'll need to come back into here and refresh. Is finished done running yet? No. Okay, there we go. So I'll now reload my extension, go back to the options page, add in our little test key value, and now if I refresh, we don't have it. So we're not saving the data anywhere at the end of the day. So the main thing we're going to implement, because I have all the UI implemented and 90% of that content script already implemented. So the next thing that we're going to do is save this data into the user's browser and then load it back up on every single web page, run a search, find that key, and replace it with this specific value. So let me go ahead and walk you through the actual UI for adding those options. So that lives in this replacements manager component. So we have a whole bunch of markup here that's kind of specific to the Vuetify component library that adds all of the nice buttons and inputs. And then at the bottom here, we have this script section where we can write a little bit of Vue.js code. And we don't need, like I mentioned, you don't need to know a lot about Vue.js to kind of understand what's happening here. But let me just kind of walk through the existing workflow. We have this new key variable and new value variable that are just empty strings, and those represent the two inputs that we had on the page. And then we have this words object. By making this an object, objects have key value pairs, so this data kind of aligns itself nicely to just being stored in an object in the first place. This total words, I'm trying to remember where I actually needed this. Oh yeah, this computed property here with this total words function, not super important, just makes it so the UI knows when to actually display the list or not. So we're actually just going to go ahead and not show that code right now. We have this created function, and this is a special Vue.js function that will get run as soon as the page loads and all of our HTML content has been rendered to the page. Or not really rendered to the page, but as soon as it's available to run some code, it'll run here. So kind of the first thing that's missing from this is as soon as the page loads, we need to go fetch that list of words that was potentially already saved in the user's browser. And then we have this methods section, which just is a whole bunch of methods, event handlers that I've already implemented here. We have this save words method. That is also something we need to kind of interact with the Chrome APIs in order to pull off, because we need to save it to using the storage API somehow. We have this add words function, which there's some fancy code in here that just adds the new key and the new value as a key value pair into the object. And then as soon as we add a word, we reset those key value pairs so that the inputs are empty again. And then we make sure to save out our words at the end of the day. And then I also have some UI in there to remove a word based on its key. And this just plucks the current key off of that object, and then resaves all of our words back to the Chrome storage. And in terms of where everything is being wired up here, we're going to jump into the Vue.js markup just a little bit. Right here, this is that form that we were looking at, and we have a click handler on the add button that runs our add word function as soon as we click on the button. And then when we render out all of our words, we also create another button for the actual X icon, and we run the remove word function passing in the current key. So this is kind of the code that we already have implemented. We've walked through it now at this point, so let's go ahead and start thinking about hooking this part up. So I mentioned that the pop-up and the options page, they don't have access to all the Chrome APIs. So to implement that part, we actually need to move over to our background script. So let me jump to that background.js. Go ahead and move that out of the way. And this is just an empty file. And a big part of how browser extensions communicate is through message passing. So there are a handful of APIs that our options page and even our content script have access to, but really those APIs are limited to just what's called message passing. So an options page or a content script can pass a message to our background script. And then our background script can add an event handler to listen for those messages coming in. So we'll start by saying Chrome. In this case, we're making a Chrome extension, so most of the APIs are available under this kind of Chrome namespace. So I'll say chrome.runtime.onMessage. And onMessage gives us back a object with a few special properties, and I'm just going to grab those special properties off of that object right away. So we have a request property, a sender property, and this function actually takes in a callback. So a lot of the browser APIs are asynchronous at their core, and so a lot of these APIs you'll pass in callback functions in order to get the data that you need. So we're passing it a callback function, and the first argument to that callback function is the object I was describing. So this object has a request, a sender, and a send response. And the request and the sender are both objects in their own right, but this send response is actually another callback function that we can run as soon as we're ready to send back some kind of response to whoever sent this message. Let me see here. So the first thing that we want to do, let me run back to our replacements manager, is let's first grab the list of words that we have. When the user first runs the extension, we actually won't have any of these words. And let's actually kind of start implementing this from this side of the message. So in order to send a message, we use this kind of the same thing. We use chrome.runtime, .send message. And we pass it basically an object of kind of whatever shape we want. At the end of the day, this object is the request object on the receiving end. And another thing, I'm kind of looking ahead here. We're going to need to send multiple different types of messages to our background script, so we kind of already need some way to handle the fact that there can be more than one type of request coming in. So the first thing I'm going to do is I'm going to pass this an object with a type property so that I can differentiate in my background script which kind of event or which kind of message is coming in. And I'm just going to use a string here to identify it. So I'm going to just call this string get words. And then the second thing that I can pass is, let's see here, as the second argument to this function, I can give it a callback. And this is the callback that will be run as soon as I run the send response function back in the background script. And so theoretically, we'll come back with some words. So we'll accept that as an argument. And then all that we really have to do is, first off, when a user is first running our extension, there will be no words. So we kind of got to check and see if it's like undefined at the beginning, which is what it will be if our user hasn't saved any words previously. So I'll first run a check to see if we actually have any words. And then if we do, Vue.js makes it really easy to update the UI by just updating our data. So I have this.words up here in data, and all I need to do is just set it to this incoming words variable from our background script. And Vue.js will handle automatically updating the UI for us. So now we have what it takes to get the words from this end. Now we need to go back to the background script and actually grab them. So the first thing we do, I mentioned that there can be multiple types of messages potentially. So let's first check what the request type is. That's kind of where I stored the message. So we'll say request, if request dot type, because remember the request argument here is that object that we passed into the send message function. So if request dot type is equal to get words, then we'll run some code. And so the next bit of thing we need to implement is the is grabbing this data from storage. So we'll say chrome.storage, and I'm using the sync option here. There's another option, I think it's just local. Sync will automatically sync this data to the currently signed in user's Google account, and then it'll be available on other browsers. I kind of mentioned this feature earlier. And I don't have to worry about whether they're signed in or not. Underneath the hood, Chrome will just kind of figure out whether it should just store it locally if they're not signed in. So we can use the API as if they were signed in and it'll still work. And we're going to go ahead and say get, because we need to get some data from storage. And essentially we just pass in an array of keys. So I'm going to store all of the words in a key called words, so we can access it via words. When I save these words in a few minutes, I'll have to make sure that I use the same key. And then as the second argument, we pass in a callback function. Remember I mentioned that a lot of these APIs are very asynchronous. So even something as simple as getting something from storage, we have to make asynchronous by passing in a callback function. So in this callback function, we will get the result, which it will literally just be whatever we saved in before. So at this point, we can run this send response callback and just pass in the result. Now, an interesting thing about the onMessage handler There's several ways to send a message back. The easiest by far is to just use this send response callback. But Chrome expects the send response callback to be run synchronously, which is not happening if we're passing it in via a callback. But we can get around that by just simply returning true from our onMessage handler. Then Google Chrome will say, okay, I know that this send response will happen at some point later, and everything should work appropriately. If we were just doing some synchronous operation, we wouldn't have to worry about this. Okay, so at this point, we should be able to send in words. Let me make sure this code is good. I may have missed something, just in case. I'm going to put .words here. You'll maybe see why in a little later. It's just an organizational thing so that I know at the end of later when I'm reading this code that I'm specifically returning words. We'll just need to make sure that when we save the data that we store it in the same format. Okay, so now we have the ability to get words that we previously saved. Now let's run back to our replacements manager and implement the save words function. So whenever we save a word, we're going to go ahead and use the same kind of pattern. We're going to go and say chrome.runtime.sendMessage. And I'm going to keep that same format of an object with a special type property so that I can tell which type of message is coming in. And this one will specifically be save words, so we can run some different functionality on the other end. And in this case, we're also going to pass in some words, and I'll just have that on a words property. Yeah, words. And we'll set that property equal to this .words. Okay, so now let's run back to our background script and add the specific event handling for this. We're already listening for the event, so we just need to tell which type of request it is. So we'll say request.type is equal to save words. That's what we used earlier. And whenever we want to save the words, the API is super similar. We just say chrome.storage.sync.set, and then we give it the Oh, never mind. I told you wrong earlier in this result section. Result will be an object where every key is the key from storage that you specified. So when I'm setting storage, I need to specify the key just by setting it to an object and passing in the request.words. So there was a specific reason for me needing to add result.words here, because you can technically grab more than one key from storage at a time, and so they just automatically add all the data from that key onto the object that comes back. And so when we save it, we save an object with the key that we want to use later. So we set words equal to the incoming words from the other end of the extension. Okay, so at this point, we should be able to go test this in our browser. So let me go ahead and start up the build process to build all of this code, because the Vue.js code won't run in an actual browser. And then
should it be request.words or result.words?
Are we just calling the storage like object result in the first one?
right here,
Yeah.
that is our specific naming.
I meant the fact that that's an object.
Yeah, so something I'll mention right here where we're using request.words, we do need to do this because this request is coming from the onMessage handler. So it does need to be request in this specific instance. Okay, is our code ready to go? I think so. Let's run back to Google Chrome, go to extensions here, and I'm going to reload and go to our options page. And we'll say test. Awesome. Test. And click add. And if we reload, dang it. All right, what went wrong?
There was an errors thing earlier on the extension.
Oh, there was?
Yeah.
Let's see.
That guy?
Errors, yep. Chrome.runtime.onMessage. Oh, yep, I did that wrong. It's supposed to be onMessage. dot add listener. There we go. Thank you. Okay. It wouldn't be live coding without some problems. Okay, now let's go back to our options page. Test. Super awesome. Test. Okay. It adds it. Dang, okay, what's going on this time? Let's see if there's any more errors. There's another one. Request.type is equal to get words. Cannot read property. Type of undefined.
Get words
I think it's back in here. Runtime.send message. Type get words. Let me see. I do. I can always jump back if this really doesn't work. Okay, let's jump back into the background and see what's happening. Request. Don't have an extra set of parentheses. Okay, we'll just check out the finished code. Let's see. Let's go ahead and do, whoops. Check out master. Oh, we'll just throw it all away. Okay. What's different? I'm not totally sure it was up there. Yeah. Not sure. Okay. Now it should work. And before I demo it, let's just go ahead and look at the last bit of code that we needed to implement, and that's here in content.js. So I already had all of this written a second ago. I'm importing this library from NPM called find and replace DOM text. It'll automatically, we can just give it an HTML element and it'll do all the fancy searching that needs to happen to find the actual text we care about and replace it. And I pass in some words. I check that we actually got some because, once again, there's the potential that when the extension first runs, words will actually be undefined. And then we just loop through all of those words and run the find replace DOM text function, passing in the current body of the document. And then the last part to hook up was just this chrome.runtime.send message, where we passed in the type of get words and then run this callback as soon as it comes back. So that was the rest of the code we had to implement. If we want to go back to the background script, we can just kind of check to see that
Was that maybe the undefined part?
It actually technically could have been. I may not have been actually handling that totally correctly. Let's see if it actually works now. I did try it several times. Oh, we need to build the code again. My bad. This code looks really similar to before. Was I returning true last time? I might not have been doing that. I can't remember if I was doing that or not. Anyways, let's wait for this to finish. Okay. Now if we reload, I think these errors are left over from last time. So at this point it should work. Test. Let's actually do one we can go test on a real web page. I'll replace blog with like articles or something. I think I have the word blog on my personal website somewhere. Add this, refresh, they stay. Okay, so something's right about my real code. Now let's pop open my personal website, and I should have the word blog on there somewhere, and it automatically updated it to articles. You may have seen that flash that happens because we have to kind of wait for all of the code on my site to run before we can start up my code, the extension code. But yeah, that's the rest of the extension and the rest of the presentation, mostly. One more thing that I'll mention real quick is that what I for the UI part of things, I mentioned I was using Vue.js. And I'm also using, the actual UI part is part of a single page application, which means everything is kind of being powered by a single HTML file. And normally you'd have to specify separate HTML files for your options and pop-up page, but you can kind of get around that by using Vue.js's what they call a hash bang router, which means that every route is prefixed with the hash, And so as far as the browser is concerned, it's loading the same file in both places, but Vue.js just kind of checks for that hash pop-up and only shows the code I had for the pop-up. And then when we're on options, it only shows the page for the options. I think that's it. Is there any questions?
Just to be silly, for the list of words, those definitely run one at a time, right? So you could be like blog, turn into article, and article.
Yes, you could. But we wouldn't run into an infinite loop because it will just do one right after the other and not start over. So you could kind of just do something silly like that. But yes, you're right. Any other questions? Yes.
Yeah. So as far as publishing these extensions, does Google, as far as Chrome, does Google have any sort of like review process? Because a lot of those APIs give you some, you can do some nasty damage with that.
Yes, you can. So that's an excellent question. There isn't near as good of a formal review process as there is with like native Android and iOS apps. I think a big reason behind that is even though these have access to a lot of stuff, they are sort of siloed off. The only real thing that they have in place is you have to pay a fee to create a developer account in order to upload the extension. It's very cheap. It's only like $5. But that's kind of the only thing they have in place. I'm not sure about the rest of the extension store. I probably imagine Safari charges a whole bunch, but because that's what they do. But there is a little bit in place from preventing spammers by at least charging a little bit of money up front. Yeah. He is absolutely right. There is some really nasty stuff that can be pulled off using extensions. I don't think I mentioned this API, but there is an entire network API that allows you to intercept, block, and alter network requests, and every single one that goes through the browser. If you install a nasty extension, it could do some stuff like modifying page content before it actually makes it to you, which is definitely a little scary. So be wary of the browser extensions that you do install. Also, they are web apps at the end of the day, so there are extensions. I've heard of extensions like trying to steal passwords because they totally have that ability. Because if you ever type a password into a web page, it could be listening for that and send that off to a server somewhere. So definitely be wary of the extensions that you install, and don't just install them for fun. Most of the major ones out there are somewhat trustworthy. Yes?
Is there an extension that stops extensions from being added? Because like literally every 2 days I have to go onto my son's laptop and uninstall all the extensions that he's magically gotten.
So that's actually a little bit of a different problem. You probably have a modified version of your browser installed that's automatically installing those extensions, or another piece of malware on your computer that is automatically installing those extensions.
What's it from Roblox?
Ooh. You could also potentially have a like cracked version of Roblox or something.
Okay. So maybe just delete everything.
Yeah, then maybe wipe the computer. It could potentially have some nasties on there. I worked at like a local computer repair shop for 2 years, kind of removing viruses from people's computers, and we ran into that exact same problem all the time, and it was usually virus related and some malware.
That's a weird hobby to just go pick up extensions.
Yeah, it's usually like something he's downloaded, then it automatically he has like 4 new extensions installed in one
Right.
day, and I'm like, you're 8, you don't install
Mm-hmm.
extensions.
Yeah, yep. Yeah, definitely get that checked out. Any other questions? Okay, well, thank you for coming. Let me know afterwards if you have any questions. I'll be hanging around for a few minutes. And I'm always down to talk about anything tech related, so hit me up if you have questions. Thank you, though.